Have you ever, settled in to watch something online, maybe a movie or a live game, and the picture's just blurry?
Yeah.
Or maybe it's got that annoying, noisy texture, or it just keeps stopping to buffer. It happens all the time, right? But imagine if every single video, whether it's brand new or some classic archive stuff, was always sharp, delivered without a hitch, and just looked perfect. Welcome to the Deep Dive. Today, we're really getting into something that's often invisible, but honestly super important. Video noise management and enhancement. It's really changing how we see everything. For this deep dive, we've been looking at some technical documents from a company, focusing on their GPU-powered platform and this whole suite of video enhancement tools they offer. So our mission today is to unpack how this tech isn't just like fixing fuzzy videos. It's genuinely revolutionizing quality and efficiency right across the board, from the moment it's filmed through production, streaming, and even how we store it long term. Okay, let's unpack this. When we talk about noise in video, yeah, maybe we think of old home movies, that grainy look. But it's way more than just aesthetics, isn't it? Why is noise such a big and maybe costly problem for video delivery?
You're absolutely right. It's much deeper than just how it looks. Noise actually gets in the way of the fundamental process of video encoding, compression. Think about it like this. Video codecs, the things that make video files small enough to stream, they work by finding and chucking out redundant information, stuff that doesn't change much frame to frame.
Right, looking for similarities.
Exactly. But what's fascinating here is when you introduce noise, all those random little variations, it actually masks that redundancy. It tricks the encoder into thinking there's more unique detail than there really is.
So it sees noise as actual information.
Precisely. And that forces the encoder to work harder, often discarding real image details just to hit the target file size. Plus, on a technical level, noise really messes with the encoder's ability to track motion accurately. It struggles to define correct motion vectors, which are basically directions for how pixels move. Inaccurate vectors means sending extra unnecessary data. Wasted bandwidth. And in situations like statistical multiplexing, that's where multiple video streams share one pipe, basically a noisy stream hogs bandwidth, and can actually drag down the quality for everyone sharing that connection.
Wow. So it's not just annoying for me watching at home, it's a real headache for the broadcasters and streamers. Costs them bandwidth, degrades quality for potentially millions. That really clarifies the challenge. So this is where Wavelet Beam comes in, right? With their core solution, this GPU-powered video enhancement, offered as a SaaS platform. How does that core offering tackle this pervasive noise problem?
Yeah, exactly. Their main thing is this automatic, very fast GPU-based denoising application. It's designed with low delay in mind too, and it works really well on pretty much everything from pristine raw camera footage straight off the set to video that's already been compressed maybe multiple times.
Okay.
The aim is what they term ultimate quality for any resolution, any bandwidth. The idea is to help standardize quality across, say, a whole video-on-demand library.
Making old and new content look consistently good.
Precisely. Making sure everything from old 35mm film scans to the latest digital content looks its best, even at really low byte rates. It's about optimizing right down to the pixel level.
That sounds like a really solid foundation. But, different parts of the video world have different headaches. Live TV is different from restoring an old movie. And here's where it gets really interesting. Wavelet Beam has this Iris suite, right? Specialized tools for specific problems. Let's start with the base. Iris itself. Foundational file-based noise management, they call it. What's that about?
Iris is definitely the foundation for working with video files. Its core job is actually quite smart. It helps the encoder tell the difference between genuine image detail and just random noise.
Okay. So it's not just blindly removing fuzziness.
Not at all. And that distinction is key.
Yeah.
It lets you achieve what's called higher perceived resolution. The video just looks sharper, clearer to us, and crucially, it allows for massive bitrate reductions. They claim up to 40% potentially without losing that visual quality.
40%, that's huge for storage and delivery costs.
It really is. And practically speaking, it's designed to be fully automatic, easy to slot into existing setups, whether that's server farms on-site or in the cloud. Plus, it's built for scale and efficiency, so you can process huge archives without needing masses of hardware.
Okay, 40% less data for massive libraries without losing quality. That's a game changer.
Yeah.
But how do you translate that intelligence into making, say, better decisions for encoding new content? That seems to be where Iris Analyst fits in.
Right. Iris Analyst is focused on enabling smarter encoding strategies, things like per title, per shot, or content adaptive encoding.
So not just one setting for everything.
Exactly. Instead of a blunt approach, It analyzes the video deeply, looking at spatial complexity, how much things change over time, the temporal aspect. It understands that noise and grain are part of the signal. By properly accounting for that, it guides the encoder to make much more efficient choices. They've confirmed bitrate savings of up to 30% just by using this analysis.
And how does it do that analysis?
Well, it has features like automatically picking the right noise profiles for the content, measuring the actual resolution without needing special charts, and quantifying noise using standard metrics like PSNR.
Peak signal-to-noise ratio.
Right. And also VMAF, which is a more modern metric trying to model how humans actually perceive quality. It even looks at contrast and brightness to fine-tune the encoding.
Okay, so we've covered files, optimizing encoding, but live broadcasts, real time, that must be incredibly demanding. Delay is killer, quality has to be perfect instantly.
Absolutely. For live production, they have Iris Broadcast. Think of it as a high-performance, GPU-powered DVNR digital video noise reducer built for the pressures of real time.
How powerful are we talking?
It scales very well. They say it can handle 8 or more 1080p streams simultaneously on just one GPU, and you can scale that up with multiple GPUs for UHD, even 8K pipelines, all with extremely low, almost imperceptible delay.
Impressive specs. This raises an important question, though. What makes Iris Broadcast different from just, a standard noise filter you might apply?
That's a great question. It's not just about scrubbing away the visible noise. The key phrase they use is lifting the signal out of the noise floor.
Lifting the signal.
Yeah.
What does that mean practically?
Imagine trying to hear someone whispering in a really noisy room. A simple noise filter might just turn down the volume on everything, including the whisper, maybe making it muffled.
Yeah.
But lifting the signal is like somehow isolating and boosting just that whisper, making it clear and understandable without losing the subtle details or blurring everything else in the process. It's about potentially recovering information that was almost lost in the noise, going beyond what traditional methods might do.
That's a fantastic analogy. You're not just cleaning, you're actually rescuing detail.
Yeah.
Now, let's talk AI.
Yeah.
It's everywhere.
Yeah.
How does noise play into AI-driven video stuff, like upscaling old standard def content to HD or 4K?
Oh, it's massively important. It's actually critical that you denoise the video properly before you let any AI upscaling algorithms loose on it.
Why is that?
It's pretty simple, really. If the source video is noisy, the AI can get confused. It might look at random noise patterns and think, that must be fine detail, and then try to enhance that.
Leading to weird artifacts.
Exactly. You end up with unnatural, often ugly results, and the overall quality can actually be worse. So Iris.ai combines their advanced denoising first, and then applies powerful deep learning for the upscaling. By feeding the AI a truly clean signal, it can focus on enhancing the actual image content, not the noise. The result is much sharper, more natural-looking details, and a genuine resolution improvement, perfect for remastering or archive restoration.
Makes total sense. Garbage in, garbage out, even for AI.
Yeah.
Okay, let's rewind right back to the source, the camera itself. Raw data. What are the specific noise challenges right at that initial capture stage?
Good point. Most modern digital cameras use what's called a single-chip Bayer sensor. Each pixel only captures red, green, or blue, not all three.
Right, the color filter array.
Precisely. So to create a full-color image, the camera's processor, or software later, has to interpolate, essentially guess the two missing colors for every single pixel. This is called debayering.
And noise affects this guessing process.
Hugely. Noise in that initial sensor signal can really distort the debayering, leading to inaccurate colors, weird patterns, and less fine detail. So Iris Raw is designed to reduce noise levels before that debayering step even happens.
Cleaning the signal right at the source.
Exactly. This results in significantly higher effective resolution and much better high dynamic range, or HDR, performance. It gives you a really pristine starting point for high-end editing and color grading, especially in demanding 4K, 6K, or even 12K workflows.
And presumably doing that heavy lifting early on frees up processing power later.
That's another big benefit. Offloading that intense denoising frees up your main CPU and GPU resources for other critical post-production tasks like effects or rendering.
Okay, we've covered the whole Iris suite, piece by piece. Let's zoom out a bit and connect this to the bigger picture in the industry. The ongoing codec wars, the push for ever more efficient video compression. How does smart noise management fit into that future?
It's absolutely central, especially with newer codecs like AV1. The video codec world is always pushing for better efficiency, and AV1 is a major step. What's really interesting about AV1 is it's the first big codec to have mandatory support for something called film grain synthesis.
Film grain synthesis, so it can add grain back after compressing.
Exactly. And if we connect this to the bigger picture, this allows for potentially huge bitrate savings. Wavelet Beam mentions confirmed 30% savings while actually improving how the image feels, its perceived quality. That's real efficiency.
How does that work? Removing noise saves bits, adding grain later costs bits.
How does it save overall? Because encoding natural, complex film grain is incredibly hard for traditional block-based encoders, especially at low bitrates. They tend to either smooth it out, losing the texture, or distort it into ugly, flickering, or blocking artifacts. Things that metrics like PSNR or even VMA-F might not fully capture, but our eyes definitely notice.
I see. So you remove the hard-to-encode natural grain noise first, compress the underlying clean image very efficiently, and then add back controlled synthesized grain at the decoder end.
Precisely. You get the efficiency and the desired aesthetic.
Yeah.
And it underlines that professional noise management, like Wavelet Beam's approach, isn't just slapping on a filter. It's serious high-performance computing. We're talking thousands of lines of optimized COD code, leveraging GPU power.
Right, it's a complex process.
Definitely. So the key takeaway here, I think, is that properly integrating intelligent noise management into the workflow once, early on, is a really smart, future-proof strategy. It doesn't matter as much which codec you end up using downstream, AV1, VBC, whatever comes next. You've already prepared the content for maximum quality and efficiency. It brings the focus back to the actual visual quality, not just chasing lower bitrates.
So what does this all mean? We've talked tech, algorithms, codecs. But what about the people actually doing the work? The studios, the broadcasters, the archivists dealing with mountains of footage. It sounds like Wavelet Beam offers more than just software. They have professional services, too. Getting hands-on.
Absolutely. Beyond the tools, they offer services to help clients actually use them effectively and tackle specific projects. This includes things like cleaning up existing video libraries or doing full film restorations to meet modern standards, like for UHD TVs.
What kind of services specifically?
Well, they offer hands-on training and consulting, particularly around FFmpeg. That's a really powerful open-source video toolkit. They cover understanding quality metrics like VMA FPSNR, how to optimize streaming bitrate ladders, automating tasks on Linux, analyzing files, practical stuff. They also act as independent consultants for comparing different video encoders. Companies need reliable, unbiased numbers, and Wavelet Beam provides that, along with the necessary computing power for proper testing.
That sounds valuable, making informed choices.
Yeah, and something quite unique is their partnership with Cinelab London. They offer vendor-neutral 35mm film test strips and analysis. This helps diagnose problems with film scanners themselves, things like sensor aging, dead pixels, increasing noise over time, issues that can subtly degrade scans if you're not careful.
Catching problems before they ruin archive scans. Makes sense.
Right. And then there's broader expertise in GPU workflows, project management, CUDA development, deep learning for video analysis, plus general consultancy for digital TV and film projects. It's really about offering the whole package, the tools, and the expertise to make the most of them.
We've certainly covered a lot today. We went from really getting a handle on how seemingly small things like video noise have this huge ripple effect, all the way to exploring this whole ecosystem of GPU-powered solutions that are genuinely changing the game for video quality and efficiency. It's clearly not just about making things look a tiny bit tidier.
Not at all. When you put all these pieces together, they lead to video that is demonstrably cleaner, definitely sharper, and much, much more efficient to store and deliver. Whether it's live streaming, VOD, or preserving archives for decades, it's about raising the bar for the entire visual experience, making sure content truly looks its best, regardless of its age or destination.
So, what does this all mean for you listening? Whether you make video, distribute it, or just enjoy watching it. Think about how common high-res screens are now, 4K TVs, Retina displays on phones. The expectation for pristine quality, even for stuff filmed decades ago, is just going higher and higher. So here's something to think about. What really stands out to you about how this kind of intelligent noise management can fundamentally change how we see video? How it can make even old archive footage feel vibrant and modern? And what are the bigger implications of that for the people creating and sharing content in the years ahead?